This video is talking about lesson 102 in pre-calculus and trigonometry, which is solving trig equations with double angles. Our first example, we have sine of 2 theta is equal to 0.6587, and we're restricting this to values between 0 and 2 pi, values of theta between 0 and 2 pi. So let's look at how these are a little bit different than what we've done before. Before we had just regular theta in there. We maybe had theta plus a radian or degree value. And now we have a few kind of special rules that go along with this. It's not too much different, but they're enough that it's going to change how you do these a little bit. So the first thing we need to make sure you do is make sure your calculator is in radian mode. And then we're going to draw where sine is positive here. And sine is positive in the first and second quadrants. And the thing that's special about this is that all our values are going to, for 2 theta, all our values for 2 theta are going to be in the first and second quadrants, okay? So let's figure out what 2 theta is equal to. So we want to take the inverse sine of 0.6587, and we will get 0.7191. Now that's in the first quadrant, so we are good. Give me 1 second here. Okay. Now we need to figure out what our next value is going to be. And you might ask, okay, well, how many different angles am I going to need? Well, the special thing about these is that we're going to have 4 angles for each of these problems that have a 2 theta. If it's a squared, like a function squared of 2 theta, we're going to double the amount of angles that we have. So if it's a squared of 2 theta, we'll have 8 angles instead of 4. And if you have something of 3 theta, like cosine of 3 theta, you're going to end up with 6 different answers because each time you're going to be in 2 quadrants and you want 3 answers for each quadrant, okay? The reason that all of these angles are going to be in the first and second quadrant is that when we then divide by 2 to solve for theta, we're going to have all our answers between 0 and 2 pi or 0 and 360, depending on the whatever mode that we're in. So right away, we need to figure out our other angle measures. So we're going to go 3.14 minus 0.7191 to get 2.4209. We're going to go 6.28 plus 0.7191. Again, this angle is coming all the way clear back around here because we've got this one, and now we need to do one that comes all the way around to back to this angle right there. Sorry for the messy look there. Anyway, 6.28 plus 0.7191 is 6.9991. Excuse me, I know I wrote a 9 there. Should be 6. And then 6.28 plus 3.14, we could do that, or we could come back to our other angle in our second quadrant, 2.4209, and add 6.28 to that to get 8.7009. Because this is our reference angle, this guy right here is our reference angle. If we add a whole rotation, like going all the way back around, that's adding 2 pi or 6.28, and that's how we get 8.7009, and that's also how we get 6.9991 from 0.7191. Okay, so now that we have our angles for 2 theta, we now need to find our angles for theta. That means we need to divide each of these angles by 2. So we're going to start with our 0.7191 to find our theta angle. theta equals 0.3596. 2.4209 divided by 2 is 1.21045. Sorry about my phone going off. And let's actually round this. Sorry, I was distracted there for a second. Let's round this to 1.2105. Okay, 6.9991 divided by 2 is 3.4996. Again, if you're looking right here, this is just 3.14 now. Instead of a whole rotation around, we're doing a half rotation. 3.14 plus, very close to that. 3.14 plus our original, or plus that top angle. We need to do 8.7009 divided by 2, and we get 4.3505. So there's our theta angles for that one. Let's quickly look at a squared one. Of course, this is cotangent. We need to change it to tangent squared of 2 theta, and that's going to be 9 over 13. Square root both sides. Tangent of 2 theta is equal to plus or minus the square root of 9 over 13. And now we need to take the inverse tangent of square root of 9 over 13. So 2 theta equals 0.693, well, let's go with 0.6940. Okay. Now, where is tangent, positive and negative? Well, all our quadrants, that's great. So we are going to end up with 8 different answers for this, so sit tight as we go through these. It's not too bad, okay? So we have our 0.6940. We need to figure out our reference angle, so we're going to do our 3.14 minus 0.6940, get 2.446, 3.14 plus 0.6940, 3.834, 6.28 minus 0.6940, 5.586. And now to get our second set of angles, we can just add 360. And I honestly just realized I was in radian mode, so let me back up here just a second. Sorry for wasting your time. Just sit tight with me for a second. If you caught that, awesome. Maybe a brownie point is in your future. Good job. Okay, let's redo this really quickly. So we need the inverse tangent of square root of 9 over 13. Okay, here we go. This is 39.7. We'll go 0.8 degrees. Okay, so 180 minus 39.8 is 140.2 degrees. 180 plus 39.8, 219.8 degrees, and then 360 minus 39.8 is 320.2 degrees. Okay, now just like with 2 pi, remember this is 360, so we can add 360 to each of these values. I'm just going to list these right next to them. So 360 plus 39.8 is 399.8 degrees. 140.2 plus 360 is 500.2 degrees. 219.8 plus 360 is 579.8 degrees. And 320.2 plus 360 is 680.2 degrees. Now, you might be saying that, this is terrible amount of work. Yes, I know, it's long, sorry. We'll get through this together, okay? So, we need to divide each of these by 2 now. So 39.8 divided by 2 is 19.9. So theta is 19.9 degrees. And I'm going to get the rest of these done here. Just for you, it'll be a few seconds. I'm going to pause my video. Okay, so this is what your answers should look like for theta. If you want to pause this and check your answers, that's fine. I just divided all of these degree measures by 2. So this is tedious. Your homework will be a little bit shorter today. Please remember to text me or email me if you have a question. Again, I'm available between 8 and 5 every day. So if you could text me during that time, that would be awesome. I will get back to you as soon as I can. Have a great day.